This is Sudharsan from 2nd BTech, 2nd semester, nominal as 244G5A0330 from Mechanical Engineering Department. So I'd want to discuss about the CE2 as manufacturing process, the topic as solidification of casting, course code as 23MEC401. So solidification of castings, understanding the process and its implications in manufacturing. Let us go what is briefly about introduction, the solidification of casting. The presentation explores the mechanisms and significance of solidification in metal casting, outlining key process factors including solidification and quality control measures. Overview. Definition of solidification. So we want to know what is the solidification. Solidification is the process through which a liquid transforms into a solid as it cools. In casting, this involves the cooling of molten metal until it reaches a solid state. Nothing but it is the cooling process of the molten metal which we have performed to process the product. So we know that solidification means in the forming or forging we have to we can heat the metal above the recrystallization or below the melting point. It reaches red hot and we change it into required shape. After that we have to reduce that heat or temperature by using of solidification. So in this method, in this solidification we have so much methods like air cooling, water cooling. In this air cooling we have to place the specimen or material into open area, but as in the liquid cooling we have to quench it into the water or water pool. That's it. So importance in casting. Solidification is crucial in casting as it influences the physical and mechanical properties of the final product. It affects strength, durability and other attributes essential for functional application. We all know that while I said in the previous slide, because of this cooling, the properties of the metal will improve. Mechanical properties, chemical, physical and properties will be improved as it affects about the strength, durability and ductility which the metal want to withstand, for the which we have to application depend on the application. So types of castings, we have the several types of castings. There are several types of metal casting including sand casting, die casting, investment casting and permanent mold casting, each serving different applications and offering distinct benefits. Solidification process. Let us see how the solidification process will work. So nucleation is the initial state of solidification where small particles from within the liquid metal. The process can be influenced by temperature, impurities and other factors playing a crucial role in the microstructure of the solidified casting. Nothing but it is the grain structure formation. We all know that. Crystal growth. After nucleation, crystal growth occurs as surrounding liquid metals. Metal continues to solidify onto the existing nuclei. The growth rate and pattern affects the mechanical properties of the final product. So the cooling rate affects the rate at which the molten metal cools significantly impacts the grain structure, overall quality of the casting. Faster cooling often leads to finer microstructures, whereas slower cooling can result in corner structures. Because in this cooling rate means how the duration we have to spend for this solidification depends on the more time we had the large number of large size of grains. Because of the short time, we have the fine microstructures and nucleus will be formed. Now let us see factors influencing solidification. So alloy composition, the composition of the metals means the composition means uh, composition alloy composition. The composition of the alloy directly influences the solidification process. Direct tenuement can later after alloy composition. The composition of the alloy directly influences the solidification process. Direct elements can alter melting points, fluidify, and grain structure, which are crucial for the mechanical properties of the casting. So mold materials. So can we see the mold materials? So mold materials. The choice of mold materials affects heat transfer and solidification rates. Materials like sand, metal, or ceramic each have unique thermal properties that influence the cooling process and final characteristics of the casting. So pouring temperature. So while we let us take the example of sand casting. While we have to pour the molten metal into mold cavity, so the temperature which we have to required on that particular time, let us see the temperature at which metal is poured into the molds impacts solidification behavior and final properties. Proper pouring temperature ensures optimal flow and minimum defects during casting. Because of this minimal requirement of particular temperature of the pouring molten metal into the mold cavity, so depending on this we can gain the accurate product like good properties, mechanical, physical. That's it. So defects in casting. Shrinkage defects. Shrinkage defects occurs when the metal cools and contracts, leading to voids or cracks in the casting. Understanding and controlling the solidification process can help mitigate these issues. Porosity. Porosity is characterized by tiny holes or voids within a metal casting, often resulting from trapped gases during solidification. It weakens the material and affects its integrity. Surface cracks. Surface cracks can occur as a result of thermal stresses during the cooling. During the cooling of the casting, proper management of cooling rates and mold design can help reduce these defects. So fifth one, quality control. So inspection methods. Quality control in casting involves various inspection techniques such as a visual inspection, dimensional checks, and non-destructive testing methods like X-ray or ultrasonic testing to ensure product integrity. Testing techniques. Testing techniques include mechanical testing such as tensile compression and fatigue tests, which validate the strength and durability of the casting against specific standards. Enhancement strategies. Enhancement strategies involves optimizing the solidification process through better and designs, alloy modification, and process parameters to improve the quality of the final casting. So let us conclude this topic. So conclusions. Understanding the solidification process and qualities affecting casting is crucial for producing high quality metal components. Effective management of this process minimizes defects and enhances functionality. Overall, in the solidification of casting, we have to consider the whole defects in the casting. For minimizing these defects, we have to make the proper solidification process for avoiding the porosity, voids, surface cracks, etc. So it plays a crucial role in the sand casting. Sand casting. So that's it. Thank you, sir. Thank you for giving this opportunity.